Hi there guys, welcome back to the Tower Tech. It's the second episode of Geek School. We're going to learn all about what components you need in a water cooling loop and which order you need them in. It's time to go to Geek School. In the last episode we looked at the way in which water cooling works. We had the analogy of a fire being the CPU generating heat going up through a pan. We talked about conduction, convection and radiation. In this episode we're going to be slightly more practical and we're going to look at the actual things that you need in a water cooling loop to move the heat away from the CPU and radiate that out into the atmosphere. Actually, there's someone who's quite interested in this, who watched the last video, who has come prepared and is ready to show us the way in which to do it. Ah, Professor, you look like you've come prepared. Did you watch the last video? Great! Have you got the bits and pieces that you need then to build a water cooling loop? It was an analogy. It's not real. That's not how you build a real water cooling loop. Let me explain. We need a pump. The pump has a housing. Inside the housing we have an impeller. An impeller is different to a propeller in as much that it is inside a housing. Water flows into the pump. The impeller rotates, moves the water from the top of the pump out into the loop and pushes water round into the loop. We need a reservoir to hold the fluid that is going to circulate in the loop. Initially, when we first fill the loop, water is going to cascade down in the reservoir and out through the tubing in the bottom. Technically a reservoir, yes. Is that something that can fit in there? No. You've got problems. We need a water block. This water block can be on either the GPU or the CPU. Water will flow in through one inlet, over some metal fins inside the block that will transfer heat, and then back out of the block, back into the loop. Then we have a radiator. The radiator has a metal chassis. It has pipes that flow through the chassis, through which the water passes. Between the various pipes are metal fins. These fins get hot and they radiate the heat out into the atmosphere. The distance between the fins is measured in fins per inch, or fin density. The closer the fins are together, the harder the air is to push between them and the more noise it generates. However, the greater the fin density, the more heat is radiated into the atmosphere. The amount of fin density that you want is dependent on the amount of heat being generated in your loop and the amount of noise that you are prepared to tolerate. Fluid flows in through an inlet into the radiator, through the pipes, and out through an outlet, back into the loop. Okay, I'll concede that one. That is actually a radiator. You'd have to have the PC case of the Century to fit it in, but it does the same thing, radiates heat. So in the last video we talked about the process of conduction, the metal in the CPU block, the atoms within it vibrating together, moving the heat away from the CPU into the water. Then the process of convection, assisted by the pump, moving the heat up into the radiator, and the process of radiation, moving that up into the atmosphere. Now, the reality is, it doesn't actually matter which order you put the components in that loop. Some very, very complicated fluid dynamics at play, horrible, horrible equations that we're just not going to get into. It's quite boring, it takes quite a number of years to understand it. It's not for now and it's not for this channel. Now let's look at what happens when you combine all of these together in a loop. In the top right hand corner is our reservoir. Water drains out the bottom of the reservoir, which feeds into our pump. It's very important that you don't run the pump dry, it will damage the impeller. Water flows into the pump and is pushed out by the impeller out to the side. Water then flows into our water block on our GPU or CPU, cooling the CPU, taking water out of the outlet. The water then flows into the radiator, heats up the fins and radiates this heat out into the atmosphere. The water then flows back into the reservoir and completes our loop. Hopefully that's all made sense. As you can see, the basic concepts of water cooling actually are pretty straightforward. The things that we take for granted in our everyday lives, we all have, particularly in the UK, radiators in a house. Do come back to the next episode of Geek School, where we'll start to get into how you actually use the components. We're going to start off with radiators. I'm going to show you how you flush a radiator. It's really important you do that. If you're not already subscribed, please do so by hitting the button here, and I'll see you in the next video.